So in this video, we're going to talk about compound inequalities. In the last one, we talked about or statements. So in this video, we're going to talk about and statements. So just to remind you, when you see and in a compound inequality, it means the intersection or where those sets are overlapping, the parts that they have in common is what we're talking about. All right, so let's start off with one like this. If we have negative 4x plus 4 is greater than 16 and 3 parenthesis x minus 2 is less than or equal to 0. So we're going to solve these inequalities separately and then put them together on a graph. So our three things that we're asked to do are solve, graph, and then we want to write our answer in interval notation. All right, so let's start with the one on the left here. So we're trying to isolate x, get x by itself, so that means we need to move the 4. It's connected by addition, so let's subtract 4 on both sides. That will give us negative 4x on the left side and 12 on the right side, and make sure you keep that inequality sign going down. Then to get x by itself here, it's connected by multiplication, so we need to divide both sides by negative 4. But if we multiply or divide by a negative number with inequalities, it flips that inequality sign the other direction. All right, so that's one of the things you've got to keep in mind with inequalities, something different about them than with the equations. All right, and then on this one, since we've got parentheses, let's clear those parentheses by distributing. And then we're again trying to isolate x, so let's add 6 over. So 3x is less than or equal to 6. Divide both sides by 3 to get x by itself, so x is less than or equal to 2. All right, so now that we have both of our answers here, we're going to graph those on the same number line. All right, so both solutions on the same number line. And we want to remember that we have this and statement. So we're looking for where it's overlapping when we graph these. Okay, so let's look at this. So we've got negative 3 is somewhere down here. Put 0 here in the middle, and then 2 somewhere over here. Oops. Okay, so now let me use two different colors here. So I'm going to graph this x is less than negative 3 in purple. So that's going to be an open circle at negative 3 because it doesn't have the equal to part, so it doesn't include negative 3, but everything to the left of negative 3. All right, and then the other one, use this little blue color here. So we want when x is less than or equal to 2. So since it has the equal to part, we do have a closed in a solid circle here. And again, notice that we want everything less than, so it's still going to be everything to the left of 2. All right, so now we want to know the overlap. Where are these two sets overlapping? Now, in a lot of them, it's in between, and so some students just automatically think, oh, it's between negative 3 and 2. But I'm trying to see, where does my blue graph and my purple graph both show up? And they both show up left of negative 3. Those are the parts they have in common. So if I'm to write that down in interval notation, right, I'm going from left to right, so it's going out to negative infinity and then to negative 3, but it doesn't include 3, so we use a parenthesis, not a bracket, right? And so that's saying everything less than negative 3 are the parts where they overlap. Okay, so let's try another one, because this one is one that students kind of go, what is going on here? Well, let's make sure everybody has a good solid foundation here with this. So if I have this inequality and, let me write my other one down, 8x minus 8 is less than 3x minus 18. All right, so just like we've done, we're trying to isolate x on the left-hand side. That's going to be easiest for us to do. So try and remember to get it to the left-hand side. Let's distribute that 5 through first. And then notice that negative 5 and 9 are on the same side of the equal sign, so we're just combining those like terms together. So negative 5x minus 14 is greater than or equal to negative 9. Then we want to get x by itself, so let's add 14. So we have 5x on the left side is greater than or equal to 5 on the right side. It's connected by multiplication, so let's undo that by dividing by 5. And so that means we'll end up with x is greater than or equal to 1. All right, and let's solve the other one too. Let's get our x's on the left-hand side. So I'm going to subtract my 3x. That will leave me with 5x minus 8 on the left side, and it's less than negative 18. We're trying to get the x by itself, so let's add 8 over. So 5x is less than negative 10, and then let's divide by 5. Okay, now I've had some students ask me on something like this if they need to flip the inequality sign because the top number is negative. And you don't. Remember, it's just if you're dividing by a negative number. So what these bottom numbers are here. Since those are not negative, we keep our inequality going that same direction. Okay. All right, now let's make a number line over here. Wow, that number line is kind of crazy looking. All right, so I've got negative 2 somewhere here and 1 here. But look what happens on this one. So again, I'm going to graph these separately. So let me graph this one first. X is greater than or equal to 1. So I've got a closed-in circle, and then I want all the stuff that's bigger than 1. So all the stuff to the right. Okay, and then my other one is this. And so it doesn't have the equal to part, it's just a less than. So I'm going to do an open circle there and everything to the left. All right, so now let's go back to what my statement is. I've got an and statement. So remember that this means I want the parts that overlap, right? But if I look at my graph, I'm saying my graph doesn't. There's no place where the blue one and the purple one are overlapping each other. And so since there is no overlap, that means there's no solution. And so sometimes we'll write that as does not exist or DNE, right? So that would be what we have here. There is no place where these two inequalities are going to have the same answers, right? Where they have the same solutions, where they overlap each other. All right, let's try one more on this. And I want to do one that is an and statement, but it doesn't say the word and in it. Instead, it looks like this. So we've got negative 5 is less than or equal to 4x plus 3, which is less than 19. So notice that on this one, it's kind of different because there's 3 different parts. Where usually up here, we just have a left side of an inequality and then the right side of an inequality. But here we have 3 parts, so we call this a tripartite. And so what we do on this, one way we can solve it, and there's more than one way to do this, but one way that you can do this is to get the x by itself in the middle. So if we were thinking, okay, how am I going to get x by itself in the middle? Well, I want to move my 3 over first, right? I'm always doing my add and subtract first when I'm solving, and then my multiplier divide. So if I subtract 3 here, And then in the past we said, okay, we'd subtract 3 here. But we have 3 different parts this time, so we need to subtract 3 here also, right? Because in the middle, we're getting rid of that, right? So there's no 3 left there, but I've got to make sure that I'm subtracting 3 from those other 2 parts. All right, so let's see what we're left with. So we've got -8 is less than or equal to 4x, so we still have 4x in the middle, is less than 16. Right, 19 minus 3 gives us the 16. All right, so we're still trying to get x by itself in the middle, and it's connected by multiplication, so I can undo that by dividing all 3 parts by 4. Right? And when I do that, I get -2 is less than or equal to x, which is less than 4. Right? Or another way that you can read this, that I'd like to encourage you to try and think of it as, is this really says, I mean, look at literally x is between -2 and 4. So think of it that way. X is between -2, okay, and it includes -2 and 4. All right? But that's going to help us with our graphing it, because when we have these tripartites, they're always going to be and statements. So there's always going to be an overlap on these. And so that means that we have, so here's my -2, here's my 4, and at -2, right, the part of x that's connected to -2 has the equal to part. So I need to make sure that I put in my closed circle, right? And then on my 4, it doesn't have the equal to part. So that means I'm going to not have the closed circle, but an open circle instead. And then I want all of the stuff that is between -2, including -2 and 4. And so that would be all this stuff in between here. So when I write that out in interval notation, I say, whoops, I need a bracket there, right? Because I have a closed circle. It had an equal to part on it. So let's make sure we get that right. So we've got a bracket, -2, parenthesis 4, and then a parenthesis there because it's an open circle. All right, so -2 comma 4, and one side is the bracket because it includes it. The other side is a parenthesis because it doesn't include it. All right, I hope you found that helpful.